All right, example 5 from 6.2. We're given the tangent of alpha for alpha in quadrant 2, tangent of beta for beta in quadrant 4. We're supposed to find the sine of alpha plus beta, cosine of alpha plus beta, and tangent of alpha minus beta. So the first thing I want to do before I figure out what the sine, cosine, or tangent of these sums of angles are is I want to use the information they give me about alpha and beta in order to determine some stuff about the sine, cosine, and tangent values of those specific angles. So looking at the information given for alpha, first of all it tells me I'm in quadrant 2. Another way they can give me that information, they can say that alpha is between pi over 2 and pi. Yeah, that's right. Pi over 2 and pi over here, second quadrant. All right, if I'm going to draw the second quadrant, I just have to draw the second quadrant. So the first, third, and fourth quadrants are all kind of dismissed here. We're just focusing only on the second quadrant. And I know that alpha lives in the second quadrant, so I'm going to draw a vector up into the second quadrant like so, from the origin, like that. I go from the vector to the x-axis to identify the angle alpha, and I go directly down to the x-axis to create a right angle. Again, I'm in the second quadrant, so to get to the x-axis from the tip of my vector, I got to go down to get there. For alpha, the opposite side is the vertical, the adjacent side is the horizontal, the hypotenuse is the slanted side, right? And we know that tangent is defined as opposite over adjacent. So I know that the opposite side's measure is 4, the adjacent side's measure is 3. Notice I didn't put any signs on those numbers yet. But just the opposite side 4, the adjacent side 3. And then looking at the direction I got to go to get where I'm going. So if I'm going from here to here, I'm going left, that's a -3. If I go from here to here, that's up, that's a +4. So the horizontal and the vertical directions are either positive or negative depending on direction from the origin to the end of the vector. So if I'm starting here, I go left, negative, up, positive to end up at the position of the vector itself. All right? Then if I just do a simple little Pythagorean triple, 3, 4, 5 right triangle. Yep. You can also use the Pythagorean theorem. Keep in mind, -3 squared is still +9. So if you're going to do the Pythagorean theorem, negative or positive, when you square those sides, you get positives. But Pythagorean triples happen a lot in these, so look for that possibility. Once I've got all three sides identified, opposite 4, adjacent -3, and hypotenuse 5, then I can very easily find the sine of alpha, which is going to be 4/5, the cosine of alpha, which is going to be -3/5, and the tangent of alpha, which is going to be -4/3. If all I needed was the tangent, I already got that, right? But again, sine, cosine, I've got to do those. So chances are I need the sine and cosine of alpha, so I went ahead and found it. The other thing they tell me about an angle is that tangent of beta is -5/12 for beta in quadrant 4. So now I'm in quadrant 4. And again, another way they could tell me would be that beta lives between -3 pi over 2 to 2 pi. 270 degrees to 360 degrees, depending how they want to identify it. So if I draw quadrant 4, again, quadrants 1, 2, and 3, just kind of small, but quadrant 4 is here. I want to draw beta, the vector, into quadrant 4. Beta is from the vector to the x-axis. And then I draw vertically from the end of the vector directly to the x-axis at a right angle. Once again, they give me a tangent, which means they're giving me the opposite and the adjacent sides. For beta, the opposite side is the vertical, the adjacent side is the horizontal. So opposite side is 5, adjacent side is 12. Again, I'm just putting the numbers, not signs right now. If I'm going from the origin out to my vector here, so I'm going to the right, which is +12, going down is a -5. There's where a minus sign goes to make that a negative tangent. And again, in Pythagorean triple world, 5, 12, 13 is Pythagorean triple. Hypotenuse is always positive. I forgot to mention on the first one, hypotenuse is always positive, never negative. All right. So opposite -5, adjacent +12, hypotenuse 13. The sine of beta is opposite over hypotenuse. The cosine of beta is adjacent over hypotenuse. And the tangent of beta is opposite over adjacent. And just like that, I've gotten a whole bunch of information about these two angles, alpha and beta. I know the sine, cosine, and tangent of each of those angles. And this box of information is going to be very helpful to find what they're asking me to find, which is these three things. So let's start off with the sine of alpha plus beta. If we look on our identity sheet under number 32, the sine of alpha plus, or x plus or minus y is how it's listed there. We have a plus, okay, so then we're going to do that properly. So sine of alpha plus beta is going to be sine of alpha cosine of beta plus cosine of alpha sine of beta. So we transform it from its current structure, which has alpha plus beta as the angle, and break it apart into these simpler angles, sines and cosines of alpha and beta, of which we have exact values over here of each of those objects. Then I simply substitute what I know. Sine of alpha is equal to 4/5. According to that, cosine of beta is equal to 12/13. Plus cosine of alpha is equal to negative 3/5. That's being multiplied by sine of beta, which is negative 5/13. And then I simply have to simplify that expression. Notice the 5's here would reduce, but the denominator is 65. This denominator is also 65. I'm trying to add fractions, so reducing is probably not a good idea. It's legal to do it, but it's going to be counterproductive to our purpose. So I would not reduce in this step. So 4 times 12 is 48. 5 times 13 is 65. Negative, negative, positive makes a positive. 3 times 5 on top is 15. 5 times 13 is 65. Since they're both over 65, adding the fractions is now legal, so 63 over 65. And that's going to equal the sine of alpha plus beta. All right. The second object here, we're supposed to find the cosine of alpha plus beta. So again, looking at my sheet, my trig identity sheet, cosine of angle plus or minus angle tells me to do cosine of both angles, change the sign, and then do sine of both angles. Okay, so on number 33, when it says the minus plus, all minus plus means is whatever this sign is, you change it to the opposite there. And again, cosine and sine of alpha and beta are all known right over there, so it's just a matter of substituting them in and working it out. So cosine of alpha is negative 3/5. Cosine of beta is positive 12/13. Minus sine of alpha is 4/5. And sine of beta is negative 5/13. Again, you can see some reduction possibilities there, but you don't want to do that because common denominators exist when you don't reduce. Negative 3 times 12 makes negative 36 on top. 5 times 13 is 65 on the bottom. Minus minus makes a plus. 4 times 5 is 20 on top. 5 times 13 on the bottom is 65. Negative 36 plus 20 is negative 16 over 65. That equals the cosine of alpha plus beta. And the final thing they asked me for is tangent of alpha minus beta. Alright, so if I look at number 34 on my sheet, I think it's 34, right? Tangent of x plus or minus y, 34? Sounds good. It's not somewhere near 34. Tangent of alpha plus beta is going to be, or sorry, alpha minus beta is going to be tangent of alpha minus tangent of beta over 1 plus tangent of alpha tangent of beta. Okay, so again, I have an identity that tells me exactly how the sum here translates into just alpha and beta, which I have information about tangent of alpha and tangent of beta, so I'm able to substitute those things in. So tangent of alpha is negative 4/3, being subtracted by tangent of beta, which is negative 5/12, being divided by 1 plus tangent of alpha times tangent of beta. All right. When you're doing tangent of a sum or difference, your expressions tend to look like this. You're going to get a bunch of fractions more often than not. Tangents are usually fractions. They don't have to be. They can be whole numbers, but they're more often than not, these problems are going to be fractions. So expect this expression always to look kind of like this. All right. If it was plus instead of minus, this would be a plus, that would be a minus, but it still have all those fractions in it. So the main goal here now is to make this the prettiest fraction possible, and I need you guys to have a little patience with the top. All right. So what I'm going to do here is I'm going to deal with minus-minus situations. So negative 4/3 plus 5/12. So I'm going to do that. But I don't want to worry about the fact there's fractions in the numerator until I get this term right here. There's always a product happening right there. I want that simplified. And reduction of fractions here is helpful. All right? Where here we were adding or subtracting fractions. Here I want to get the smallest denominator possible because I'm trying to get a least common denominator to get my best expression. So the fact that this 4 and this 12 reduced to a 3, that's helpful. So I'm going to get 1. And then minus minus makes a plus. On top, 1 times 5 makes 5. On the bottom, 3 times 3 makes 9. And again, 5/9 is better than 20/36. All right? So reducing fractions there is useful. At this point, looking at the expression, at the structure of the expression, I've got fractions inside of fractions, so I want to multiply by the least common denominator of all those fractions, which would be 36 times 36 times every object, even the non-fractions. So if I do that, 36 divided by 3 is 12 times negative 4 is negative 48. Plus 36 divided by 12 is 3 times 5 is 15. On the bottom, 36 times 1 is 36. 36 divided by 9 is 4 times positive 5 is positive 20. Add or subtract, negative 48 plus 15 is negative 33. 36 plus 20 is 56. That's the tangent of alpha minus beta. When you're doing your homework of this variety, if they ask for all that, fine, but I think more often than not they ask for one or the other. So they might ask for this, they might ask for that, they might ask for that. They might ask for all three, I don't know. Pay attention to alpha plus beta, alpha minus beta, that order, that matters because of the correct sign to be used in the expression that you're going to go with. But again, priority 1 is to take the information given to figure out the sine, cosine, and tangent of both angles individually. Then you have some numbers to substitute into the expressions based on the identities.